Let's take a look at cut planes in AutoCAD architecture. Now, specifically in this overview, I'm going to talk about cut planes as they reflect or impact walls, doors, and windows. You can extrapolate to DWAs, maybe even curtain walls, but the subject of cut planes on stairs, slabs, and roofs would be best done in a separate YouTube video because they are a bit different than the walls and the doors and windows. I've got two scenarios here on the screen. I will start with the one on the right, just a regular wall here. Now, this is one of Archidyme's custom walls from our products. And if I scroll down here, I pulled this one in here. This is a horizontal siding, kind of like a hardy board siding material. If you zoom in a little bit, you'll see it's got the siding, plywood, studs, sheetrock, and insulation inside of it. But it's pretty much like any wall that you would find in AutoCAD. It'll work, it'll serve for this demonstration. But for the doors and windows, I'll use the absolute generic stuff that comes in every AutoCAD architecture file. So let's go change this wall a little bit to make it more interesting for this subject. And what I'm going to do is pick the wall, right-click, go to the Edit in Place, right-click again, add a gable, click right here, enter. And so now I've got something that offers a more interesting situation for discussing cut planes on walls. So this would be like a gable end wall where you've got your roof coming out over the top. Let's go to top view. Okay, and let's go back to 2D wireframe. So this is the medium detail. Notice down here the global cut plane, which would also be correct to say the absolute versus relative. This is an absolute cut plane. It's set to 3'6". You can run that whatever value you want. Just because they start with 3'6" doesn't mean that that works best in your drawings. I've sometimes found 0 works. Typically I find 4 feet or 5 feet. And you will know why I'm talking about setting it differently if you've done things like high bathroom windows, you know, in the shower or tub scenario. You'll know why you want to work with that cut plane. And if you can't win with it, what we're going to discuss and take a look at right now should help. These other two values are not cut planes. Don't confuse them with cut planes. They are just ranges. The cut is actually occurring at this value, and then the 1,000 feet is how high it will find anything above, and the -10 is how far it'll find anything to display as below. But that's below and above that value right there, the 3'6". Okay, so I will do a window add. And now we'll bring in the standard window that's in every AutoCAD architecture file, and its default value seems to be here at 3 feet, 5 feet with a, let's go down here. It has a head height of 6'8". That's fine for residential. And it's also set to center, so that's fine. So I'm going to pop that in, and that works exactly the way you want. Now, if I were to go to the global cut plane and I were to move that up to, say, 7 feet, this is what will happen. Okay, it'll disappear. That's because you're now looking at a point above that window. Let's put it back. All right, let's go ahead and rotate into 3D. Let's copy that window up. I'm going to copy it up about 8 feet. And I'm going to make it a little bit smaller so we can see it. 2 feet and 2 feet. Okay. So it is now sitting at a head height of 14.8. I can also change that to sill. So the sill height is, let's make the sill height 12 feet. There we go. All right, now we go to top view, and I hit escape. I don't see that window. Often, if I have this type of a gable end scenario, I want to have the window display because I'm going to tag it, and I also want the contractor to understand that I either have an existing case of a clear story, or it might be a vent or just a decorative window, but I want that shown in my 2D plan view. So what can we do? Well, the first place to start is with the object itself. Now, there's basically three places you can work on this problem at. You can work on it with the global cut plane, you can work on it on the wall, or you can work on it on the window. The window anchors to the wall, and the wall responds to the global cut plane. But we'll look at overrides. So first thing here, we'll select the window. I'm selecting that window that I see because both are the same. If they're not the same, you would have to go into 3D, find the other one, this one here, and work on it. Okay, edit the window style. Then you would go to plan view, and you'd have to decide, are you going to do an override for this whole style, or are you just going to affect all the windows? Okay, hopefully you understand the difference between the overrides and so forth. In this discussion, I'm just going to talk about cut planes. So I'm going to ignore the overrides. We'll go to the plan view of that window because plan is used in medium detail. On the other tab, you'll see that there is a use cut plane of containing object when anchored. Now, if you uncheck that, this object will ignore the cut plane of whatever it's anchored to. It becomes its own, it has its own cut plane, but it's not one that you can modify. So it's default plan view. Now you'll see this on doors and windows, and I'm pretty sure on DWAs. So let's just see what that looks like. So if I go ahead and do that and go back to top, what happens is now, regardless of what I set down here, I can go and set this thing to 20 feet. So that's the global cut plane. Notice it affects the walls, but not the window. And if those had been doors, not the doors. It's kind of a powerful override. We just go, look, I don't have time to figure anything out. Just show me the object, and this will work. I have done it, but it's not the best because you can see what happens here. I'm not able to differentiate very well above and below. So I will undo, but be aware that is a, I'll undo again. And undo again, and let's go down to the top. Okay. So it's a powerful tool. We'll go back to edit the window. We'll go to plan, and we'll make sure, yeah, let's keep that cut plane of the anchored object available. But let's go over here and take a look at the layer color line type. So notice that there is information here, display component information for above and below, and you will see the same for doors. So what I can do here is I can say, hey, this is an above scenario. I would like the above information to be shown. So let's go ahead and turn it on. Then we'll go over here and decide what to do with the display, how it's shown when you print it or on your plan. Like for me, I would typically go to what I think of as a lighter color, and I would set a line type hidden 2, and I would knock that down to 0.5, so it's even smaller than hidden 2. And now I should see that separately, but clearly. So there it is. It's now shown as above, and I can tag it. I can select it to tag, and I can put a window tag on both of those windows. All right. So that's pretty much what I can offer regarding this type of scenario where you have a window above another window, whether it be the same window or a different style. That's pretty much what I can offer there. Now we'll go over to the second scenario. In this scenario, I'll go ahead and do a realistic on it. This is something I run into in the San Francisco Bay Area quite a bit, is hillside homes. There's nothing but hills around here. Well, there was some flat land, but a lot of stuff here is staggered somehow on the foundations. And what happens is you have to make a decision of whether to split your project into multiple constructs for the different levels, which makes controlling the cut planes easier, but it doesn't necessarily make managing your building or your project in your sheets easier. It becomes more complex because you have to consider where do the walls stop. I think everybody would prefer to work like Revit, where it's a single building model. You just do it all as one model, but that's not the way that AutoCAD architecture was designed. So there are people who do it. I don't see it as a very feasible process. I break everything up. But in this scenario, let's address a case where you don't want to break it up. It doesn't really make any sense. And what can we do with the cut planes? So to finish this work off, I'm going to do a floor line. I'm going to select the wall, enter. I'm going to go down and select the foundation down below. And what that just did is it projected the stud wall to the foundation. That's very similar to what I did over here for the gable. Now I would never do my foundation in the same construct as my walls. I just have them here to explain or demonstrate why you would run into a situation like this. I am going to go ahead and go to layer. And let's see. First off, I'm going to take those walls and I'm going to stick them on a different layer footing, and then I'll go ahead and just freeze that layer. Let's see here. Boom. We'll get this out. Okay. I don't need those in the way of this demonstration. So just so we're aware, this is a wall that now goes down below the 0 and definitely below the global cut plane. We'll do a top view. All right, go back to 2D wireframe. Let's do window, add, and let's pop in, let's see, what do we have here? 3x5 with a head height of 6'8". Yeah, that's fine. We'll pop one in here, and we'll pop one in here. Now we'll go back into this view. All right, now if we see, they're like the other wall, so we shouldn't expect any issues. Go to top view. Let's go top. Okay. So that's why everything is looking pretty good, is I can see that window, I can see that window, and let's see, if we take a look at the wall here and go to plan, we should, that red line, that is the below cut plane line in our custom wall that has been turned on. It's also been set to the layer wall below. So that's a good indicator that there's something occurring in the wall, and it's controlled by layer, LA. So you can go in here and change its color. You could make it yellow or whatever you want, so it would read something like this. Okay, so now it's yellow. So that's kind of cool. You can turn it on and off. Now, let's make that window a window for, let's say, the lower level. So that means down here somewhere. Now, one of the problems with having walls that have been projected as a solution to the level is that the wall doesn't know that this is the sill area of the wall in this area. It's only seeing this portion as the sill. So when a window is selected, it's reading its value from that sill. When I want to put this, say 6'8" from down there, it has no idea what I'm talking about. I mean, it does relative to that sill, but that puts me into the negative world. It's one of the reasons I really don't like working on walls that are done this way. However, that does occur, that I just choose to do it, but now I got to track all that stuff in my mind. And I'm not going to calculate it here in this exercise or demonstration. I'm just going to go ahead and pop it down like that. Now I purposely brought it below the 0 here because I want to take a look at those scenarios. Now if that makes you uncomfortable, I'll just bring the window up like that. So there, the floor might be down there. All right. So now what happens in the top view is I lose that window. Now I can do some different things to try to bring it back. Among them is I can overrule the display of it. I can go ahead and select the window, right click, edit here, I can go to plan view, and I can just say ignore that cut plane. We saw that, and this is what happens. Now the problem is, well, there's more problems. See, it affected this over here, so that's not cool. But it's not actually solving the proper presentation of a window in a wall problem. The wall is not disappearing below. And I can save you some time. I don't need to do all the different demonstrations. We could tinker with all the different settings. You can't fix this problem as far as I know, and that is because of this. I'm going to go back here, and I'm going to put this back on. And there are no other window things we can tinker with. We're going to go to the wall now. We're going to edit the wall, and we're going to go to plan, and now we're going to jump over to other in that wall. Now notice, here's what they offer. Hide lines below openings at the cut plane. That is the most common way that you deal with your doors and windows, openings, and DWAs. The objects that go into the wall usually cut through your cut plane, so you want to remove the lines of the wall. The next one down is hide lines below openings above the cut plane. Okay, that's kind of useful for transoms, um, clear stories, things like that. However, where's the next one? Where's hide lines below openings below the cut plane? Not there. They didn't offer that. So there isn't anything that you can do to win the war of clearing out the line work of a wall that is that low in this type of scenario. The only thing you can do is you can attempt to go the other direction. You can say, well, let me either change the global cut plane to something low. So I could say minus 4 feet. I think that's low enough. Yeah, I might want to go lower, minus 6 feet. That was too low. Let's do an undo. Trying to figure out how low is that. Let's see. I want to come down to about, and then just snap to this. I want to go right through the window. So that is on the Y, minus 13. Oh, where's the Y? Minus 2. Yeah, minus 2 something. So let's set this to minus 2'2", and go back to top. UW. Let's go to the top. Okay, so there we go. So what we're seeing now is that the global cut plane was moved down low enough to properly show the lower portion, but I lose the top portion. And then, we get into this battle because that affected all the other objects. So you can see, even though I can get some of this stuff to show, I can go to the wall, and I can go here, and I can go to here, and I can say show the above items. I'm not really winning this battle. So what we can do is we'll go back and set this to 3'6". Okay, so the global cut plane is out, but we can override that on the wall itself. We can edit the wall. We can go to cut plane, and we can do an override. So I could say minus 2'2" on that wall. All right, same problem. Now, I did an override to the wall style, not the wall itself. I could have done that, but I'm not winning this battle. I'm ending up with this stuff, and it's because of what I explained. They did not set up a scenario for where you can cut the lines out from objects below the cut plane in the wall. So I could go over here and I could make this thing try to look. It's just too painful. It's an interesting scenario to work on, to learn about your options and your limits, but let's take a look at maybe a better way. So I'm going to undo. I'll leave this stuff, that's fine. What I'm going to do now is what I typically will do on a project. I'm going to break the wall. I'm going to break it right here twice. Oops, I missed something. Let's get the foundation back on so we know where I need to be. Okay, so, so this needs to be pulled over to there. Okay, good enough. Okay, so what we have now is we have this scenario, okay, and because I broke it, it lost the floor line stuff. Yeah, and that's fine. I don't want the floor line stuff anymore anyway. So I will take this wall and I will make its origin the bottom here. So I'm going to go ahead and move from this corner here, dot Z down to here, like so. Okay, so now when I pick that window, I can actually think of that window relative to how I would normally see the floor. So I can say, well, the head height is going to be 6'8". All right, and then I can track that properly. That is, and it'll show up in the schedule properly as 6'8" above the finished floor. And then I could just bring this wall up, however. Let's just assume it goes up to here. So 2 different walls. Oops, a little bit of a snap issue here. Snap to this. Sometimes when you have one of the shaded views on, it doesn't want to snap properly. Okay. And then for more advanced users, what you do to keep that line out between those two things when you're doing your projected elevations is you use the merge common material setting. I'll just quickly show you that. So you, when you do elevations or sections, it uses the model, and you go to other, and you'll, oops, sorry, you go to materials. This is the exterior siding. You go to the properties of the materials, general, medium, detail, other, and then you'll see right here where it has merge common material. So that will prevent a line, usually, pretty good, maybe 80% of the time. It will not show a line where those two walls come together like that. Now let's take a look at the top view because we're really talking about cut planes. And let's freeze that layer. Footing. Okay. All right. And let's go back to this. All right. The global cut plane is 3'6". Let's edit the wall and go back to the cut plane. Let's take off the override. Okay. And so this is looking good over here. That's looking good over here. But this one is not happy. Now, what I can do is I can go ahead and take advantage of that override now. I can go in and I can say, how about a 3'6" relative? This is now relative to the wall itself. It's an override on that style. Watch what happens. Okay, now I have success, and it didn't ruin anything over here. The reason this is working is because I told that wall style that I want from its base, from its bottom, 3'6" up, not the global cut plane anymore. So the global cut plane doesn't matter. I can set the global cut plane to 20 feet, and you'd think all of this stuff would just disappear. But the wall now has a relative setting from its bottom up 3'6". And that's why it's showing both the way that I really want them. And then, but be aware that the global cut plane no longer for this medium detail no longer controls that. And it's the wall. So whatever gets put into the wall, anchored to the wall, will now read that same cut plane. So if we go to the window, plan, you'll notice back here on the other, see, it says use the cut plane of the containing object when anchored. So the cut plane of this object, this wall, has now been set to a relative 3'6". So hopefully this information will help you in dealing with tricky situations where you have above and below anchored objects in walls. And I'll probably do another discussion on slabs and floor slabs and roof slabs. I'm out.